Dear students, welcome back to my class. So now we are moving to the next trends in taxonomy, that is called the numerical taxonomy. In the previous classes we have discussed about zero taxonomy as well as chemotaxonomy. Now we are moving to the numerical taxonomy. So let's move into the detail of this one. What does mean by numerical taxonomy? Numerical taxonomy means here we are classifying, or it's a method of classifying organisms on the basis of numerical methods. For more clearly, this is the branch of science in which the classification is mainly done with respect to the number, or numerical. Numerical in the sense of number of similarities as well as dissimilarities. So if we are considering similarities, if we are classifying organisms on the basis of similarities as well as dissimilarities, we can clarify the degree of relationship between them. Okay, so this numerical taxonomy is nothing but it is a method of classifying organisms by taking the consideration of similarities as well as dissimilarities for revealing the evolutionary relationships. This particular branch has started in 1957 to 1961 with the initiation of or the initiative of a famous scientist that is called Michael Adamson. He who planned to assign numerical values to the similarities between organisms, and he proposed that equal weightage should be given to all the characters while we are studying. So Michael Adamson was the first scientist who initiated the emergence of this particular branch, and he classified organisms on the basis of the similarities as well as dissimilarities. And while he is classifying these organisms, he generally provided equal weightage to all the characters while we are studying. So if we are taking 5 different characters, he generally gave equal weightage for all these 5 characters. Later, the Michael Adamson was getting replaced by another scientist, that is called Robert R. Sokal and Peter H. Smith. These two scientists in 1963 divided this particular field into kinetics. Kinetics is another branch of science, and this scientist later comes just after Michael Adamson, and who proposed another branch of science that is called kinetics. And this kinetics was generally based upon the classification. It is mainly based upon the behavioral similarities. Then, what are the aspects of this numerical taxonomy? How we are considering this numerical taxonomy? It involves the following 2 different steps: construction of taxonomy groups and discrimination of taxonomy groups. What is meant by construction of taxonomy groups? Here, while we are studying, we have to select the individuals, and we need to select these individuals with respect to this particular characters which is getting supported. So if we are considering larger number of character or more number of character for classification, better will be the approach of this numerical taxonomy. I told you that numerical taxonomy is mainly concerned with the classifying organisms on the basis of similarities. So here if we are considering more number of characters, we can say that it will introduce the construction of taxonomy groups. Then a discrimination. While we are considering this different kinds of groups, we need to discriminate the taxonomic groups. When the taxonomy characters are taken for the study, it shows overlapping of characters. Discrimination should be useful to select them. So here what we are doing is first we need to construct the taxonomy character with respect to certain features. And if we are considering, for example, if we are considering 10 to 20 different kinds of taxonomy groups, in which certain groups are overlapping in nature with respect to certain characters, we need to separate or discriminate all these taxonomy groups. So this is called as discrimination of taxonomic group. Then what are the principles behind this numerical taxonomy? just I told you, if you are considering more number of characters or more number of phrases, it generally contains the content of greater content of the information of a particular taxa. With more characters, the better will be the classification. If you are considering more and more number of characters, the classification will be better. Then, as I told you, if we are considering this much kind of characters, equal weightage has to be given for every character. Then correlation of characters should be different in different groups of organisms under study. And by means of this correlation of characters, we can distinctively recognize the different taxa. Then we need to view this each taxa and has to practice as an empirical science. That means if we are considering this different taxonomy group, we need to thoroughly view the peculiarity of each taxa with respect to the studies which I have already done in this particular taxa. That means empirical means experience. If we are, for example, if we are considering 5 different taxa, we need to review the characters which is already present in the previous classes. So, or if any studies are already done in this particular taxa, we need to refer it. Okay, so that is called the reviewal as well as practice. Then phonetic similarity or this similarity has to be done, and this will be the basis of the classification. Then what are the advantages of the numerical taxonomy? So that of conventional taxonomy. Conventional taxonomy means the character which is done by means of morphological features is generally improved by the emergence of this numerical taxonomy because it is generally provides better and more number of described characters. Conventional taxonomy is nothing but it is the taxonomy character which was already done in the very oldest time. That is the beginning of the classification, how the taxa are generally considered. That is called the conventional taxonomy. This conventional taxonomy is the conventional taxonomy is generally done by means of this conventional taxonomy is generally replaced by this particular kind of numerical taxonomy. Then many existing biological concepts have been reinterpreted in the light of numerical taxonomy. So you know that many previously existed biological concepts can be reinterpreted or can be re-evaluated by means of the emergence of this numerical taxonomy. And it allows more taxonomy characters to be done by the less highly skilled work. So these are the advantages of numerical taxonomy. Then what are the applications of numerical taxonomy? This is generally used in the study of various angiosperms or plant families in the case of plants. And here the similarities as well as the differences in the character in the bacteria and all other microorganisms can be studied by means of this numerical taxonomy. Here phytochemical details. If we are considering the classification of plants, many phytochemical details like mitochondrial DNA, RFLP, etc. are generally used for solving in the specific variation. So, in the case of numerical taxonomy, these kinds of details can be taken for the analysis of classification of organisms. So, I hope you understood. If you have any doubt, please do in the comments.